Namaste student. Today we are going to learn how to prove alternate segment theorem. So before the starting with alternate segment theorem, let's learn some definition. What does mean alternate segment? So here we have the segment which is opposite to the angle formed by a chord of a circle with the tangent at one end of its end point is called alternate segment for that angle. Let's try to understand what does this statement means. So what they are saying that if you have a circle and one chord, this is your chord and this is your tangent. Now if you take this chord, this is your what segment and this is another segment. One is minus segment. If you take this is your circle and if you take a chord, then we call this is what segment, and this is also segment, minus segment, major segment. Now what does mean your alternate segment? So here if you take this is your as a chord, and if you go this side and if you take this angle, then this is your alternate segment of this angle. And if you think about this angle, then this segment is your alternate of this angle, that is the alternate segment. So if we'll take angle BAQ, then alternate segment is BCA, this is your alternate segment. And if we'll take BAP, then alternate segment would be what, BDA or ADB, whatever you want to say. Okay, now what this statement says, so here quite long statement they have written, you just read by your own. Okay, in short, let's try to understand what does mean of this statement. Okay, so here we have saying that if you have a chord and a tangent, then the alternate segment theorem says that if we'll take this angle and if we'll take the angle formed by this chord in the alternate segment part, then this angle must be equal to this. That means if it is your 60 degree, then this must be 60 degree. Or this is another side. If you think about this one, AB is your chord and PQ is your tangent, and if you think about this is your angle, then this angle must be equal to this. If we take this is 120 degree, then this must be 120 degree. So we're going to prove this theorem. This theorem have another name, tangent-chord theorem also. Okay, so here the statement, in short, let's see the angle between a tangent and a chord. Angle between a tangent, this is your tangent, and a chord, that this is also an angle and this is another angle. Okay, two angle we have. So if we'll go with this angle, then you need to say that this angle must be equals to this, and if we'll take this angle, then this must be equals to this. This is your alternate segment theorem we need to prove. So here we have AB is a chord, yes, and PQ is a tangent at A. Now we need to prove this 1 and 2. So generally we prove only one, and the second one by similarly we'll say. So here what we're going to do, we'll do a construction. So here we need a construction. So what we're going to do, draw a diameter. We're going to draw a diameter AE. That means we'll take one end point, this is A, and diameter should pass through a center O. Okay, we'll draw a diameter AE and we'll join B to E. Okay, and our target to show that this angle must be equals to this. If we'll show, then in the last we'll say that by similarly this is also true, and hence the theorem. Okay, let's start. So here we have, so we know that this is your what, chord, and this is a segment. Remember one theorem, angle on the same segment. Yes, so here we have angle BCA equals to angle, or you can say, okay, BEA, both are equal here. Why, sir? Angles on the same segment. This is your number 1. Okay, next, angle EBA equals to what? 90 degree. Can you guess why? Yes, because if we'll take a circle and the angle in the semicircle will give you what? 90 degree. Look at, this is your center O and this is your diameter AE. That means this angle must be what? 90 degree. So this. Now, if we'll go through this triangle, that means BEA, if it is 90 degree, then sum of these two angle must be 90 degree. Why, sir? Angle sum property. That means angle, this imply, oh, we'll mention here angle in a semicircle. Okay, now this imply what? Angle BEA plus angle BAE equals to what? 90 degree. Why? Angle sum property. Okay, this is your number 2. Now, by what? Remember, tangent radius theorem. That means tangent is perpendicular to the radius. That means both will be what? 90 degree. So here by tangent radius theorem, OA is perpendicular to PQ. This imply angle OAQ equals to what? 90 degree. And this can be written as OAQ can be written as, see here, this is one angle and this is another angle, sum of these two angles. That means this angle can be written as BAE. So we'll write here angle BAE plus BAQ equals to 90 degree. This is number 3. From 1, not 1, from 2 and 3, look at here, this sum of these two will give you 90 and sum of these two will give you 90. That means both are equal here. From 2 and 3, we can say that angle BEA plus angle BAE equals to angle BAE plus angle BAQ. And you can see that BAE and BAE are equal. That means they will cancel each other. This implies angle BEA equals to angle BAQ. Now we have BEA means BCA. This implies BCA equals to angle BAQ from 1. And our target was this only. BAQ equals to BCA. Similarly, we can prove that if we'll, now you will draw this one as your target would be there. So similarly, we can say that angle BDA equals to angle BAP. Hence the theorem. Okay, thank you.